The topic of this video is graphing inequalities, specifically linear inequalities in the Cartesian plane. This is a continuation of the previous video. Okay, in our previous video we looked at this system of inequalities and we found that we had a five-sided shape, this pentagon, as our solution region, and we were able to complete all parts of the problem except for identifying and labeling the corner points, and we're going to do that right now. All right, so this is a five-sided shape, so there are 5 corners. 4 of the corners are very easy to identify simply by looking at our graph. So we can see that this point right here has an x-intercept of 2, this point here is an x-intercept of 5, this point here has a y-intercept of 2, this point here has a y-intercept of 5, and for that reason we get the following points: 2, 0, 5, 0, 0, 2, 0, 5. But the 5th point is a little bit difficult to locate. The 5th point is sitting right here. Now if you look very carefully, you can see that this brown dot is not at the intersection of a row and a column line. In other words, these little black dots. The brown dot is not sitting on top of one of these black dots. And if I were to zoom in on this part of the graph right here, this is what I would see. I've got these 4 black dots, which represent the perfect intersection of an integer line or an integer column. I've got the green and the blue lines intersecting, and the brown dot, which is our 5th corner point, is somewhere in between. So the x-coordinate is somewhere in between 3 and 4, and the y-coordinate is somewhere in between 3 and 4. And our job is to figure out where. Where is this point? So how are we going to achieve this? We can't determine it simply by looking at the graph, because how would you know? So what we need to use is an algebra approach. Let's think about it this way. This brown dot is sitting on the intersection of this dark blue line and this green line. So if we can find the intersection of those 2 lines, that will tell me the location of that brown dot. Well, finding the intersection of 2 lines is a skill we learned in a previous video. We're going to solve a system of equations using these 2 equations to find the location of that point. So we have 2x plus y equals 10, which is the equation of our green line, and we have x plus 2y equals 10, which is the equation of our dark blue line. If we solve this system of equations, it will help us identify our 5th corner point. So we can see that this is a rather challenging problem because it has an entire problem within it. It's kind of like having to solve 2 problems in one. Okay, so let's go ahead and solve this. So I'm going to label this as equation 1, and I'm going to label this as equation 2. We can use substitution or elimination here, but substitution is probably a little bit easier. So let's solve equation 1 for y. I'm going to move this 2x to the other side. So I get y equals negative 2x plus 10. And then I'm going to substitute that into equation 2. So in equation 2, everywhere I see a y, I'm going to put negative 2x plus 10. So I get x plus 2, parenthesis, negative 2x plus 10, close parenthesis, equals 10. Distributing, I get x minus 4x plus 20 equals 10. Moving the 20 to the other side, x minus 4x equals 10 minus 20. Negative 3x equals negative 10. Divide by negative 3 on both sides. We get x is equal to 10/3. So, is 10/3 between 3 and 4? The answer is yes. If you use a calculator, 10 divided by 3 is the decimal 3.3333 repeating, and therefore that gives me confidence that our answer is probably correct. But it's only half of this 5th coordinate. I also need to know the y value. So to find the y value, I need to plug in. I can plug into any equation that I want, but why not pick the one that starts with y equals, since I'm trying to find out what y equals. So I'm going to take this equation, y equals negative 2x plus 10, and I'm going to replace x with 10/3. So y equals negative 2 times 10/3 plus 10. This gives me y is equal to I can write the negative 2 as negative 2 over 1 and multiply to get negative 20 thirds. I can write 10 as 10 over 1 and then get a common denominator by multiplying by 3 top and bottom. So then I'm going to have y is equal to negative 20 thirds plus 30 thirds. When adding like fractions, you keep the common denominator and add or subtract the numerators. Negative 20 plus 30 is 10. So I get y is equal to 10 thirds. Notice that I get the same value for each coordinate. So the fifth point that I've been looking for this whole time has coordinates 10 thirds, 10 thirds. And with that, we have completed this rather long problem.